Hello and welcome to the metric style workshop on open source data analytics via Dune Spellbook. The workshop will be presented by Agaperste, Wizard Relations at Dune. The presentation will be 60 minutes. There will be question breaks where you will have the opportunity to unmute and ask your questions. However, if you are more comfortable with writing your questions, please do so in the Discord chat on the right, and Marina will read your questions during the breaks. Without further delay, let's give Agaperste a warm welcome. Agaperste, the floor is yours.
Thank you, Patrick. Thank you, Patrick, for that intro. So let me turn on my camera. Cool. So welcome to this workshop on how to do open source data analytics through Dune Spellbook. So without further ado, let's just dive into it. All right, so by the end of this workshop, you should be able to be equipped with a technical ability to claim spellbook bounties and do some open source data analytics. So let's go. So first, what is Spellbook? So Spellbook is an open source DBT repository for high-level data tables. It really enables the community to build toward a standardized way to transform data into meaningful abstraction layers. So if you don't know what DBT repository is, just think Spellbook as your Web3 community data transformation projects, right? So with the open data in Web3, you have the foundational layer, the raw tables like the transactions, traces, and logs. And then Spellbook is just really a way to help you transform those like lower level of data to a higher level abstraction layer. So examples of Spellbook are dex.trades, nft.trades. Those who have worked in our Dune system before might be very familiar with these tables. So together with SQL and Jinja, Spellbook really tries to bring software engineering best practices to data analytics work. So if you go to the Dune UI v2 version, you will be able to see kind of like on the left-hand side, there's different categories of data. So like Spellbook is its own category. Okay. So if you just came in, please mute yourself. Thank you. Yes, so that we just went over what exactly is Spellbook, like definition-wise, but let's see like why do we need Spellbook? Let's see like Spellbook in action. So a few days ago, whenever I log on to Twitter, I just kept seeing things like Renga collection related. Like I cannot have gone like scrolling without seeing Renga. So like this intrigued me, and then like this just made me want to like kind of like dig into what Renga is about, and then see like what kind of like analysis I can dig up. So normally the way I start digging is I will go to kind of like OpenSea, and then go to the Renga collection, and then I will like just randomly click into a particular item within that collection. And then that way I can kind of like already grab the collection's like address on chain, and also the unique ID associated with that particular item. And then just to kick off my like analytics journey, I'll like scroll down to the part where there's like item activity, and then I will just like kind of like click open a transaction, and then just investigate the it's on chain to begin with. So here I've listed like a sample transaction related to Renga. Then yeah, here. So, and then from here I can like kind of like see, okay, the transaction hash associated with it, like who bought it from whom, like how much money was involved in this transaction. So yeah, so I was like ready. Then the next step, let's pretend like we're in a world where we don't have a spellbook. We don't have like that higher level abstraction. We only have a base of data. So let me make this a little bigger. Okay, so here I need to query for this decoded table. So remember we're talking about like there's like three types of data. There's like the raw, which are blockchain data. So think about it as like the traces table, transactions table, logs table, and then there's like the decoded projects. So those are the data that's created by the smart contract. So if in a world where we don't have abstractions for spells, then we need to query for the decoded tables. So here I've identified that, okay, the table I need is this seaport event order fulfilled table. And then I know my transaction hash because from this side, right, like I can grab the transaction hash. And then just doing like, I spent like quite a few minutes doing this, like, and all I've got, as you can see, two things I've got, the token contract address and the token ID. And in order to get there, like, see how much work I need to do. First, I need to like already know, okay, so like offer is like the column I'm looking at. I need to like get the first position in this array, and then I need to make it a JSON and read the JSON token, and also have the knowledge of like, okay, like token contracts are like 20 bytes, which means it's like 40 characters I need to grab. And then same thing, like just to get the token ID, so much work is like has to go into it. And like I haven't even got to the part where like I'm interested in like the money that's like involved in this transaction, right? So that's just like not a sustainable way to do things, right? Like this type of work, like if someone already figured it out one time, like it should be shared across the community. And that is the beauty of like the open source community building data analytics. So same thing, we're actually more advanced things I'm doing here. So I want to be able to like start investigating this transaction for Ranga. And then you can see now I'm querying the nft.trade spell. And literally so clean, right? I can already directly query for the seller, the buyer, the amount that's being paid, the currency symbol. Like there's just like a wealth of like simple information that's like super accessible, right? So just you can see like on a micro level, I call it, just to help you investigate like a simple example. Spells are amazing. You can skip so much work. And what's more, so that's from a micro perspective. So from a macro perspective, same thing. So we're gonna use NFT marketplace as an example to kind of see it. So if you've done any kind of like NFT analytics, you will realize one of the big advantages for like where one of the things you really want to achieve is to be able to like compare across the projects across the chain to kind of like do a comparison analysis so you can understand like the position of this project, the position of this marketplace, right? But like it sounds like a simple task, but whenever you go from like a really high level, it's almost always really hard to do. So this is like an example dashboard that I'm using to try to like illustrate to you. So with the nft.trades spell that everyone builds to work with, like you can just like do really simple things. You can get like point metrics such as the total volume of all the marketplaces that are like included in nft.trades. And then also you can do like other kind of like analysis, like to get the market share of this particular NFT marketplaces. And then you can kind of also get like the trend wise, like what is the volume that like flows through these different marketplaces. And yeah, and this is like really amazing because one, you can just like access information from a higher level super easily and then conduct your analysis that way. And then two, this is like a really like an open source way to build data analytics, right? Because here you can see like by no means it's like super complete. Like we have one the top marketplaces like OpenSea and then Magic Eden stuff, but like there are more out there. And then as a community member in this open data analytics space, you are able to just like go in and be like, hey, today I'm gonna analyze and do all the data engineering that's required for sudo swap, and then I'm gonna make a pull request, and then so everyone else can benefit from my work, and then in turn, like I will also benefit, and I am benefiting from all the work that other people have done. So that's just like a really beautiful moment. Like I think for me, I get quite excited because for the first time in history, almost like we have the same set of like open data that we have access to, and then also we are able to build on top of like the same data set, and then our goal is the same, and then everyone just like learning and building in public. It's just like really amazing. Yeah, so let me close these two tabs. So yeah, so that is why we need Spellbook. So now we kind of understand what is Spellbook, why do we need it. These are the 10 steps that we're going to go through today. So by the end of it, you can call yourself an archwizard and start making pull requests and start making spells. And for those of you who don't know the reference, so Dune, at Dune, we call our users the crypto data analyst wizard. And then if you are a wizard that works on a spell book, then you become an archwizard. Okay, so number one, do some prerequisites and set up Spellbook DBT. So you should have already done all of this. So install Python 3.9, have some sort of like IDE. I have VS Code, and then make sure pip is installed, pip env is installed, and you got like Git and GitHub all like set up. And then ideally, you should have already like forked the Spellbook repo to your local and set up the upstream. So here I'm just we can quickly walk through the last step in case you haven't like pulled down the repo local. But yeah, basically go to the Spellbook repository on GitHub and then create a new fork in local. And then you don't really need to do anything, just like create a fork and you're good to go. And then once you create that fork, you go to the code dropdown and then basically copy paste the URL, and then you switch over to your IDE. So here at VS Code, and make sure like you're in the correct folder, the directory that you want to be in, and then you basically type git clone and then paste the URL, and then wait for it to download. If you haven't done this, it might take like a little bit, like a few seconds, like 10, 20 seconds-ish. It's like big repository. Okay, so now, assuming that you have a local copy of Spellbook, we're going to set up Spellbook DBT. Okay, so first, you should install the virtual env with pip env install. And then after that, you should do pip env shell. And then after that, run dbt init. And then basically follow the prompt and enter the following value. And then after that, you do a dbt deps. I'm going through this quickly because I have a video that's coming up to show you exactly what's going to happen. And then like at the very end of this, it's going to prompt you to run dbt debug. You shouldn't run this because you don't have access to the actual database. But yeah, so here's a quick video of everything that I've just gone through. So here we already have the Spellbook cloned to local. So I'm going to make sure that I'm going to be in the right folder. So I'm doing cd change directory to demo Spellbook. And then as I was saying, we should first do pip env install. And I've done this before, so it's like really fast right now. So after pip env install, then you do a pip env shell. Okay, so that activated the shell for you, and then we do the dbt init. So this part, like it's asking me to overwrite. If you have never set up a project like a dbt project before, you shouldn't see this. I have, so that's like asking me to overwrite my previous profile, but you shouldn't really see this. And then here it's going to ask you which database. You just enter one for Databricks. And then for host, you don't need to enter anything. So just like put a dot as like a placeholder. Same thing for HTTP path, like a dot as a placeholder. Token, same thing, placeholder. And then it's going to ask you the desired Unity catalog option. Just choose to not use Unity catalog. And then schema. So this part you should type wizard as your schema. And then thread, just put 2. And yeah, and then now you are good to go. See here, it tells you to run dbt debug to validate, but like you don't really have a connection. So if you run it, it's going to fail. Okay, so now we have set it up. So the next part, just to kind of like test that it's kind of working. So one more step you should do is to run dbt deps to install all the dependencies that are needed. So you see here, like screenshot, it's going to install. And then once it installs, then you should run dbt compile. And then it's going to just like compile it behind the scene. And then once it's done, what should be coming up on your directory is, so like when you clone the repo, you don't necessarily have like this folder called target, but once you run dbt compile, you should have this folder like available, and then you can even like open one just to check. So like, oops. So all it's doing is that, like, we'll go into this like a little bit more in depth, but when you define a model in dbt, you're kind of like using Jinja templating. So like the compiling process is just like help kind of resolve the templating into like actual table names. But yeah, so this is like what you should do to just like test that it kind of worked. And then one last step, just because we're gonna like try to actually do some Git stuff today. So after that, you should create a local branch by typing git checkout -b workshop. So workshop is the name of the branch. You can really do whatever you want. So here I'm just naming it workshop. And then you should do git push -u origin workshop. And then you should do that because you want to set up an upstream. So basically, like this first step only creates this this version of your code in local code workshop. But then, like in order to push it to the cloud, then you need to set up an upstream like remote hook, and this is like what you do to do it. And if you don't know what I'm talking about Git, just know that you should follow these 2 steps and create a new branch, and you're good to go. It's kind of like when you're like in examinations, right? Like you like need to put your name on like the exam paper. So like because all the papers are the same, so like then your teacher knows like this is your version of the test. Same thing. But yeah, so I will pause here a little bit for any questions that we have. I'm gonna go through the chat a little bit. Yes, will there be a Polygon NFT data in NFT.trades? Yes, in the V1 version, I think there's already dex.trades in Polygon. Correct me on that. But in V2 engine, like currently, we are still working on backfilling Polygon data, which should be available soon. And like once that's available, then you can be the one local kappa to submit a spell, and then it will be available for everyone to use. Okay. Awesome. Okay, so I'm gonna keep going, assuming that everyone has the DBT project set up. Okay, I don't see any questions. All right, awesome. Okay, so number 2 is to decide what spell to cast. So here, for this workshop, I've decided that we're going to do a migration spell. So we're going to migrate an old abstraction from V1 for the Keep3r Network called view job log. And then we're going to migrate this into a V2 version. So today we're just going to like demonstrate the process. But if you're like starting a new spell, like, I don't know, tomorrow, if there's like sunflower project that you want to start a spell with, then you would like define that as the target of your spell. But here we're just going to migrate an old one. So first step, you should open the file in your IDE. So you should go to Spellbook directory and then go to the V1 abstractions folder, and then keep traversing until you get to the view job log.sql file. Just have it open. So this will be the target of our migration today. And then after this, we are ready to set up the file structure for our SQL, schema, and source files. Okay, so setting up the structure. So we first should create a folder for the project. So you should travel to the models directory and then create a new folder called Keep3r Network. So the Keep3r is spelled like a little bit differently, like Keep3r. And then after that, so you should create a folder for the chain, because theoretically, like a project can live on different chains. So you are gonna create a nested folder under that. And then after that, you're gonna create 3 types of file. One is the SQL file, so that's where the abstraction logic goes. And then one is the schema file, is where we define the spell's purpose and add generic tests, description, metadata. And then the third is the source file, which would help define any project-specific table dependencies. So like, remember we were talking about 3 types of data that Dune has. You have the raw table, and then the decoded table, and then the spells. So like the sources file help you define like what role tables and what decoded project tables that you're dependent on. So pretty much like this is what the end result should be. Just create 3 different files for the schema, for the source, and then for view job log. Awesome. And then actually though, for the current migration that we're doing, we actually need to add 3 more SQL files. And let me show you with a quick video on why do we need to do this. So first, remember, I've asked all of us to kind of like open this this view job log SQL from V1 version, right? So if you see here, it actually depends on 2 other view, right? Because I'm saying like select from both of these tables. There's the view job log, view liquidity log, and then also the view job credits log. So I'm gonna open both of these. And then also in both of these, I'm gonna like see again to check for dependencies, like what other models or views that it's dependent on. So quick word on here. So like if you see, okay, so from Keep3r Network and then Keep3r EVT liquidity addition, like I look at this and I already know that whenever like the name is like underscore EVT, that means it's like a decoded table. So that is gonna go in the source part and not like it's not like a model that we need to reference. So we're good there. But like if I keep going down to the from, then I see, okay, here I reference a different view, which is like a different model here. And then it's view job migration. And then I go to the left side and I can see, okay, actually view job migration is a view that I also create, or the person that the visor has that person also create here. So basically so that's why like from this like traversing of like from view job log, we see that it's dependent on liquidity log, also on the credits log, and then both and also like liquidity log also depends on the migrations SQL. And yeah, so that's just like kind of like identifying. That's why we need to also create 1, 2, 3, 3 other SQL files in the process of our migration. But yeah, so after that, let me see. Oh, oops, can I? Nope, cannot. I'll escape a little bit. And then, okay, so we are ready to go to the next slide. Okay, so here is a pause point. Any questions? Okay, no questions. I feel like hopefully you are not lost, you're just following along great. Okay. Next, okay, so now we have our file structures set up. We're gonna go work on the sources. We're gonna identify the sources that we need and define them. Okay, so here is just like in case we're gonna start typing a lot. So just like in case you're lost, or in case you just like want to copy paste a bunch of things that you don't really want to type, you can click on the link and then just go here and then find the file that you want and then copy along that way in case like you're missing whatever I'm showing on the video. Okay, so here we are going to define the sources. Okay, so how are we doing that? So here I basically split my VS Code into 2 windows, left and right, and that is to help me to be able to like copy paste the sources that I've identified over, and later on I can format them, right? So on the right hand side, I have the Keep3r Network Ethereum source YAML file, and this is the file that defines the dependency for this model that we're migrating, the spell that we're doing, right? Okay, so starting from the view job log, the entry SQL file, we see that it's dependent on these other 2 views that we're going to create, the liquidity log and the credits log, okay? And then same thing here, I like to search by from, because from is like the table that you are going to query data from. So this way I can find where it's dependent upon. So here I can see, okay, these are like the decoded tables for Keep3r Network. So I'm just going to do Keep3r event liquidity addition, just like basically copy paste the table over to the right hand side. And later on, we'll do like the formatting and stuff. We'll add more meat to it. But first, we're going to find the tables that it's dependent upon. And then here we see that it's dependent on view job migration, which is like another model / spell like we're defining here. So we're going to go into that file later to copy paste the actual decoded tables it's dependent on. Okay, so now we are in the migration SQL file. Same thing, Control F for from, and then find the decoded table that it refers to, and then paste it to the right-hand side. And then just one more SQL that we need to go through. Yeah, same drill, just find the decoded table, paste it to the right-hand side so that it's ready for use. So already you can see, like, once you get the gist of it, especially when you're migrating a spell, it's like a pretty repetitive process. Like you're gonna get good at this very soon. Okay, so seems like we are done. So we've identified all the decoded tables that we're dependent on, and there's no raw tables that we're dependent on. So yeah, so it looks like we have defined the sources that we need. And next step is that we just need to format it so that it's actually like in YAML format, and then we can like give each of these table descriptions and stuff. So let me go to the next slide. And one other thing to mention, because we're migrating spells from like V1 to V2, right? So V1 engine, just like a quick word on that, if you're not familiar, it's like a different database and a different database engine. So sometimes like the names of these tables could be slightly different. Or if you're like trying to identify like a source table, right? Like if you just like I said, like if there's a sunflower project and if you want to do a spell in the sunflower project, you want to identify the sources. What do you do? So normally I would just like go to the UI and then basically try to find the table from the UI, from the data explorer side on the UI. So here I'm just showing you how to find like Keep3r Network related tables. So I type in Keep3r, search for it, and click on Keep3r, and then here I filter for events because like on the other side, if you remember, like all the table sources that we defined are basically underscore EBT. So, and then here, I think I was looking for some sort of like job related job addition, job migration successful. So here's like where I can find the table name, and then here if you see the I don't know how to call this sign, but if you click on this thing, it's gonna like auto fill the table name on the actual UI. And that's how you can like grab the name for this particular table. But yeah, so let me go to the next slide. Okay, so then we've done all the work, right? And then like we know that these are like the tables that we want because we copy pasted it over. So then we just like need to format it nicer. So basically, just we're defining the name, the name of these sources, like they belong to the Keep3r Network Ethereum, and then the tables are blah blah blah. It's like all these tables, you just name it. So this is how you can format it, and then you should put a description. I actually later on got feedback from my coworker, and I updated this a little bit to be more descriptive. But yeah, so just like try to put a description for the sources that you're defining. Okay, so another pause point for questions. Are we still doing well? Okay, cool, awesome. Okay, so now we defined the sources. We're ready to go into how define expectations. So we're gonna define. So this is the part where we like define like when we are done with the spell, like what should our spell or like what should our models look like, and what sort of like tests it should pass. Okay, so first we are going to be defining the schema. So step one is that we should list the models. Okay, so go to this file that you just created. So Keep3r Network Ethereum schema.yaml, right? And then so here, questions? All right, so you go here and then you start listing the models. So remember we created like 4 SQL files, right? Because there were 4 abstractions basically we were trying to migrate. So those views are what you call models. So yeah, so here you just like list the name of the model pretty much. And then you say, yeah, so just like list their name, view job liquidity, view job credits, you get the drill. And then after that, you should fill in the column names and descriptions for each of these models, right? So you're like defining the columns, the result of these models, and then just a word on this. So whenever you define the column names and descriptions, two symbols that you can use to help yourself. One is the ampersand. So for it to first appear for that like the first appearance of that column, you can use ampersand so that later on you can use a star to refer to it. So you don't have to define the description or the test associated with it again. If you don't know what I'm talking about, we will go see an action, an example. Okay, so this is basically the completed schema file for Keep3r Network on Ethereum chain. And what I mean is, okay, so here we're gonna like put the name of, let me actually make this bigger. So we're gonna put the name of this model, right? And we're gonna define like a bunch of metadata, config, whatnot, and then we're gonna put just a description for what this model does for us. And then here we're gonna define the columns that we're expecting to be in this model or in this view table. Okay, so this is the part with ampersand, right? So ampersand event. This is the first time I'm defining the column for the column event. So I say the name is event and the description is this. And then also you can see same thing, event index. This is the name, and then first time I'm like defining it, I'm also defining a generic test to say that the event index should never be null, and if it's null, then something is wrong, right? So you can see that like with event, the next time we refer to it. So this is the second time the event column is being referred, and then I want the event to have like the same description, like same test associated with it. So all I need to do is put a star and event. So I'm avoiding to type all the like a bunch of stuff. It will just like inherit from whatever I already defined. So later on, like one of the a big benefit of a DBT is also like it would auto generates documentations of like what this table does and what this column does. And this is the part that we're doing to help with the document generation. So like whoever goes on the DBT docs will be able to see, okay, this column means this column has these like properties, like they should not break. Okay. Cool. So anyway, so how do you find the actual columns that, on the side we saw like a bunch of columns associated with this model. So when we're migrating like this, this abstraction, right? So the easiest way is go to the Dune UI and then go to the data explorer and then basically type Keep3r view job and then find whatever abstraction that you're trying to migrate. And then you're going to be like, if you click on the drop down, then you will see the columns that are associated inside of this abstraction view. And then, yeah, you just like copy paste all these over to your schema file. And that's basically how I found out like what column that I'm expecting from this. And obviously, if you're like defining your own spell, then you should have more knowledge about like what kind of output you want in this table. Yes, I'm also noticing that I'm using view, table, abstraction spells like pretty interchangeably. Pretty much like generally like I mean the same thing. They're just like a table of view that you can select star query from. Yeah, hopefully I'm not confusing you with all these different terminologies. Yeah, so after we finish defining the schema, so like the output of our model, we're now ready to do a little bit more advanced test, right? Because like whenever we write any SQL stuff, we want to make sure like our logic is correct, and like we need to have some ways of testing, hey, like our logic is correct. So here, what we're gonna try to do is like start the process writing unit test for our spell. Okay, so step one, we need to set up seed file structure. So why do we need seed? So seed are basically like CSV files that is just data, right? That can be loaded into data warehouse. And then we use a dbt seed command. So basically like in the CSV file, it should contain the expected result. And then later on, we can like use this seed, like this data that we've just generated, this like table that we've just generated through dbt seed, and then we can use it to compare against like our actual result from our model to compare, like to see that it's correct. So okay, so first, in order to do this seed thing, we need to create file structures, like the same way that we've already done for other things. So go to the seeds folder, right? Same thing, you should create a folder for the project, Keep3r Network, and then create another folder nested inside of it called Ethereum. And then you should create a CSV file. And then you can just like name it something descriptive. Here I name it like view job log Postgres. Actually, later on, like we'll cover this part during like there's a review process whenever you submit a spell, and I'm actually told that we're trying to move away from underscore Postgres, so I actually renamed it something different. But yeah, so the gist is create the file structure, create the CSV file in this step. And then, okay, so now is a good time where we like actually understand a little bit of Keep3r Network, because in order to know what sort of results we're expecting, we should be understanding like what we are doing, right? So Keep3r Network is a marketplace for posting and accepting jobs to help run decentralized infrastructure. So if you think about Yarnwall, right, there's a bunch of like automatic were like jobs that needs to be run, to be maintained, and then in order for these jobs, these like contracts to be kicked off, like someone like one of us, right, like with an externally owned account, like that actually can sign like our signature, has to kick it off. So like those are the keepers. So basically Keep3r Network is just like a place where there's like jobs that can be claimed by the keepers, and the keepers will be rewarded in this process. If you're curious to learn more, you can go to the link to see it, and then also you can read more about Keep3r Network through their documentations. But yeah, so with that, we are ready to find the expected values for our unit test. Okay, so here I'm illustrating like how do we do that. So based on our understanding, right, I want to create a test where given a transaction hash, I want to see the amount for this particular that's awarded for this particular job, and then I want to see the keeper, so like who helped to kick off this this job, and then the token that's being paid. So here I set up the CSV structure on the other side, and then I'm just going to the Keep3r Network landing page. And then, oops, I'm going to the landing page, and then I'm going to grab like just like a random jobs that are available, click into it, and then I'm going to click on the view calls. So here is just like a list of calls that are being that were made, that like just keeps track of like, okay, which keeper kicked off which job, and like at what time, like how much money is awarded and stuff. And then if I click on it, it's actually gonna link me to a transaction. So here I'm gonna grab the transaction hash, and then I'm gonna paste it over on this side. And then the amount we saw like on the UI, it's like 0.11. So I'm gonna put it here as the expected value. And then so here, the from is the person that triggers this job. So that is the keeper in this case. So I'm gonna click the address, paste over the address, and then the token symbol. So going back to here, the UI for a keeper, we see that the token is Keep3r keeper basically. So we can find the address for the symbol pretty easily. We'll just type in Keep3r, go into it, and then we copy the address, and then we paste over it. So yeah, that's pretty much how we find one example. Let's just keep going with like a few more examples, because we don't have to create a bunch, but just like a few. That's just enough to help us like have confidence on the logic of this model that we're building. So same gist, like we're copying the amounts that's being awarded for this particular transaction, and then we're gonna find the keeper that kicked off this job, and then token is the same because it's like being awarded in keeper token. And then let's just create one more test. So gonna just like randomly click into something, gonna click into Okay, looks like this one doesn't really have anything. So we're gonna click into future rebalancing and then just pick anything. Okay, so here we're gonna copy the transaction hash again. And then we saw in the UI that it's 0.35 keeper token being awarded. And then we're gonna copy the keeper's address, the from, and then here just like double checking, yes, it's indeed KP3R token. So we're just gonna like copy paste that over. And yeah, that's like pretty much how you can construct a expected result and like use it as a so like we're going to talk about how to use it as seed, but this is how you can find out expected results. And yeah, so now we are ready to go into the next part. So with the expected results, we can now start writing our test, right? So test like the seeds, like the actual model, we're going to start setting up the file structure. So by now you're an expert already. So just go to the tests folder and then underneath it, create a folder for the project, Keep3r Network. And then underneath that, create a folder for the chain, Ethereum, and then create a SQL file where you're going to define the test for the model. So here, just going to say like view job log test. And then with that, we are finally ready to start writing this unit test. So here is a quick video on how to write a unit test. So with a unit test, we're basically trying to test if the result from the model, which we're going to define later, actually matches up with the expected result that we just like put together right through our investigation. So we're gonna define a CTE called unit test. And then, so two things we're going to choose from. We're going to choose from both the expected results and the actual result, right? So the way I can choose from my actual result is we know that we basically define, this is like our model that we're going to be defining called Keep3r Network Ethereum view job log, right? So here, the way that I can reference it is by doing double bracket and then ref and then put that there. I'm gonna talk a little bit more in depth about how and why we're referring to it in this way. This is Jinja templating, but for now, just know that this is how we can refer to our actual model. So here I'm gonna say like, okay, from this model as actual, and then I'm going to join the expected results. That is also something that we have just built, right? So here, the way we can refer to it is we're going to just copy paste the SQL file's name that we've just defined. So whatever that name is, we can just like paste it over, and that will be how Jinja templating can start like recognize it. So we're going to name that as our test. And then we're going to join on the transaction hash. So we want to start comparing like within the same, if you have the same transaction hash, meaning if you are the same transaction, does your result actually match up? So here I'm applying like a lower function just to make sure that the case doesn't matter anymore. Because sometimes the address, like, it can be uppercase, lowercase. Yeah, we want to not be concerned with that. Okay, so first test we're going to define, so make sure the amount actually matches up with the actual amount. So we're going to do this by defining a case statement. So basically, if it matches up, then it's true, then we're good to go. If it doesn't match up, then it's false. And you might be wondering, okay, like why are we doing the round? I've done a little bit digging and found out that whatever we saw on the UI for like Keep3r Network, it's actually rounded to 2 decimal point. So in order to actually match up, we are going to also apply the same round function to the second to 2 decimal point. Okay, so then we're going to define 2 other tests because here we have 3 columns, right? So we want to make sure all 3 columns match up our expectations. So we match up the result already, and then we're going to match up the keeper. So for the same transaction, we want to test that the keeper is the same keeper. So if it is, then we define as true. If it's not, then it's false, that something is wrong. But yeah, so then we again like apply the lower function, right? And then yeah, keep going. So one more for the token. And just wanting to make sure that the token that's being paid is the same. Yeah, so now we've got this. Then we are going to do the second part. So we define the unit test as whatever we have here. And then we're going to just like make sure there's no false results from this test, right? So how are we going to do that? We're going to do like a select star from this unit test where, you know, we're going to find anything if the amount test, if there's anything false in the amount test or anything false in the keeper test or token test. Actually, this is a mistake. Instead of and, we should say or. So like if any one of these three tests fails, then our test should not pass. And then there's something wrong with our model. Okay, awesome. So a quick word on the seed. So remember we were creating the CSV file, right? And then I said that like the way we can upload the CSV file data to the data warehouse is like run dbt seed. But like basically, since like Dune is such like a public project, we cannot really give public access to our data warehouse, right? Security. So wizards cannot trigger dbt seed. It's gonna fail. But instead, we've come up with another way. So there's like a GitHub Action Job that takes care of it. So if you do these two steps, push to remote and raise a PR, then a GitHub Action Job will automatically run dbt seed for you, and then your table will be created that way. So basically, what you need to do is first push to remote. So you do git and then add dot. So this just like add like make sure like all the files that you have are added, are ready to be committed. And then the second step, you commit all the files that you just added. And then you put like something descriptive about what you are just about to commit. So git commit dash and then the description. And then after that, you are going to do a git push. And then here it actually failed for me because I forgot to set up upstream. But you should have already done it if you followed along on like, you know, you already set up the upstream for workshop branch, then you should be fine. But basically, yeah, so it would like keep push your local changes to remote. And then after that, you just like raise a pull request to from your own branch to the main branch. And then if you do that, then it's gonna like kick off a like GitHub Actions. So I'm just gonna, while you're doing all of these, I'm gonna like show you what it should look like. So basically, once you have a pull request open, a GitHub action will be like kicked off for that. And then, so it just like, it will keep running these steps. And then at some point it would run dbt seed for you. And then if it successfully runs, then you will see that the file is loaded, and then this particular table is created for you. Test schema git blah 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 is created for you. Okay, so you are wondering like why does it look kind of look similar, but like not really. So like this is it adds like a hash in front of it to make sure there's no collision. And then also this table is created under the test schema for you. So basically, this just means that the dbt seed is successfully run and created for you. So the next step is like, okay, then if you go to the UI, you're able to actually directly query from this table. Yeah, so that's how you, even though you can't really run dbt seed from local, like once you, if you need it to be run and if you need the test to pass and stuff, this is what you can do to actually create that table for you. Okay, cool. I feel like we flew through like a lot of things. I'm gonna pause for a quick question. I'm gonna check the chat as well. Oops.
Questions are being typed right now in the chat.
Okay. I will wait for a few seconds and do a water break for myself. Yes, hydration break. I feel like there's just like so many things that we're like flying through. Okay, well, seems like we're good. Oh, if the tests fail in the future, who is monitoring those? I imagine, like you mean like if a test that you define it breaks in the future. I'm just gonna assume that you mean that. So it's just like whenever you submit anything new, it really shouldn't break the old test. So if anything new that you're doing break the old test, that it's like your job. Whoever like changes the logic and breaks the test should be responsible for fixing that. What is the latency of source table? Let's see. Great question. We have like a public dashboard that tracks this. Let me show you. So the latency of source table. Let's go find that. Let me first make sure it's 100%. And then I'm going to go into my creation and then dashboard. I'm gonna find the dashboard for you. Give me a sec. Okay, meta monitoring. Sorry, I'm using my old computer from like college, so if like sometimes it takes a little bit to load. I think my computer is like screaming, like, why are you doing this to me? But yeah, so here I'm gonna paste the dashboard in the chat. Um, Basically, from this dashboard, you can see like the latency of like various chain. Hopefully that helps. And let's see. Next question. Yeah, you can all unmute if you feel comfortable. But yeah, let me finish like the chats. How do you run the test.git schema file on Dune when you try to run the whole model? It times out. A whole model, it times out. How do you run the test.git schema file? Why does it like I tried to run it actually, like later on. It does not time out. It's actually pretty quick. So can you specify like what are you talking about? Like the test seed that we uploaded, like how long it takes? I'm pretty sure it was just like it was really fast, right? Yeah, 2 seconds. So few one just okay. I'm talking about the main model. Sorry. Aha. Okay, we will get there. It shouldn't really time out in most cases. Like the one that we're doing today, like it doesn't time out. So how do you run it? Like the whole thing? You just basically like you will see it, but basically like the dependencies, you're just gonna use it as like a common table abstraction, and then you're just gonna keep layering on top of each other, and then that way you can like test that your model actually runs. And that's how I do it. I usually like kind of like manually compose it to make sure that it runs. Hopefully in like a little bit we can solve your question more clearly. And then where can we find already written tests to write better tests and learn? That is a great question. So basically there's like this test folder. So like this is my Spellbook repo. And then here, if you go to tests folder, you can already see like a bunch of tests being written for other projects. And then you just like click open any of them. And then that way you can like learn. And then you can also just like consult DBT official documentation to learn more about it. Okay, so I see there's a lot of commits and requests, more than 6K, and every pull request watched by Dune's wizards before agree it. Sorry, I see that there's a lot of commits and requests, and every pull request watched by Dune's wizard before agree it. Sorry, I'm not really understanding this question. Do tendon? Do you want to come off mute? All right. Okay, we're gonna go through one more question. If you want to know more, just like ping me later. Okay, so Peter is asking, how can we use API from another data source to feed the data into a spellbook? That is a great question. That is currently not possible. So if you have like just small data you want to upload, the best way is through like dbt seed. And then if you have like a large amount of data, talk to us, talk to our engineers, and we're gonna figure some ways to help you upload the data into the data warehouse. How long does it usually take for a PR to be approved and merged? I think it really depends. Like a few days, I want to say, but I'm not sure. I'm not sure. Maybe you could go through the historical commits. I know my teammates are like really working hard to like try to clear through all the pull requests. Okay. 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 So we're gonna go back to the main presentation part. And I realized this is actually taking longer than expected. Marina, is that okay if I keep going?
Definitely good on the metric DAO side. If all of you or some of you can hang around, that would be great.
Okay. All right. So we've got a lot to talk about. Yes, it will be recorded. So if you have to go, then come back and check the recording. But otherwise, we'll start going to the next stage of this. Okay, exciting part. We're finally at the part where we can like cast the spell. We're gonna write the spell as select statement. Okay, so just a quick reminder on why we're starting with view job migration. So remember we had like four SQL tables that we created. We're gonna start by the view job migration. So why is that? So our entry point is the view job log, right? Which depends on the liquidity log and credits log SQL. Okay, so remember going into the liquidity log SQL and the credits log, they both depend on this other thing called view job migrations, and then view job migrations only depends on decoded source. So we're good there. So that is why we start from like the lowest dependencies here. So we're gonna start with view job migrations. Okay, so and then so how do we do this? View job migration SQL. So we are basically gonna go to the view job migrations V1 version. You see here's like V1 abstraction, and then the view job migration SQL. We're gonna copy, and then we're gonna paste this on the other side, and then we're gonna only keep like the middle part. So we're gonna basically delete the definition part. So we're gonna only have like the select statement, and then afterwards we're gonna start changing some syntax. So first off, instead of a Keep3r Network, we need to have Keep3r Network Ethereum. So we're going to replace that with Keep3r Network Ethereum. And then next up, we are going to make sure that we have this table. So I'm just double checking from the sources that we just defined that it is actually the table that I'm dependent upon. So I'm going to replace it with the correct syntax. So remove the double quotation. And then the space in between. So, okay, awesome. Now the source is like updated to the correct sources. And then I'm going to start working on the other part. So here we have like a select statement, right? And then the select statement is also unioned with something else. So good practice here is not to do a select star, right? Because if in the future something changes in the source table and then you do a select star, it's going to break this union. So you should always select the actual column that you want when you're doing a union statement. So that's what I'm doing. And how do I know what columns I need? So basically, I just go up top here. I can like find the columns that's being referred to from the previous part. So I'm pretty much just like copy pasting the columns that I'm identifying from up top one by one. It's a bit of like a manual job. But yeah, so just identifying the columns that I need, find it and like paste it under. And yeah, so and also just like because it's manual work, so I'm like pretty much double checking that it like I'm always checking the count if it's correct, and then once that's done, then I will, because it's like a union statement, so whatever is the top part should always match up with the bottom part, right? So I will just paste the columns over. And then now we're going to change the syntax of the upper part. So here, if you're like curious, why am I just like formatting timestamp differently? Like you might need not to do this. I have like a local formatter on my VS Code, which makes things weird. It will like uppercase timestamp. So that's why I'm doing it. But other than that, I'm just changing the syntax here. So here, if you notice, I'm basically deleting like all the encode. That is because like in V1, like all the contract are actually byte, and like in V2, all the contract address are strings already. So like it comes as it is. There's no need to like manipulate, change, transform the column anymore. So that's why I'm just like deleting it. So all I'm doing here is just like transforming the syntax from V2 version to V2 from V1 version to V2 version. And yeah, so again, here I'm just like trying to replace the not needed transformation part. And then here I'm just trying to like get the correct syntax, get rid of like the double quotation, and then make sure it's like the right column. And yeah, so that is what I'm gonna do here. And so this is like my first try on replacing the syntax. So copy paste, replace syntax. Okay, so after I do this, right, I for sure want to know if this is correct. So how do I test it? So I'm gonna copy paste literally what I just wrote. And then I'm gonna go to Dune's UI, start a new query, switch over to V2 because that's what we're developing upon. And then just paste the query over to this side. And then we're going to run. Okay, well, looks like I've got an error. So it's saying that the generate series function does not exist. So V2 is a different SQL syntax. So V2 is Spark SQL and V1 is PostgreSQL. So here I just replaced generate series with like this explode sequence 01 function. I just Googled it. I just Googled like equivalent of generate series and then replaced it. But yeah, so now I see that it generates some table results for me. So what do I do? So now I'm going to go to V1 version, and then I'm going to find Keep3r's migration view. So like the view that we're trying to migrate, I'm going to find it in V1. Actually, this is a mistake. I didn't really need to type EVT, but basically I should have typed Keep3r and then migration. And then once it shows up, we're gonna find the view job migration and then paste right hand side. And then select star from. Okay, so here, awesome. So this is the view that we're trying to migrate from, right? So ideally, this table should match up to the other table that we were just like generating on the other side. Yeah, so switch back. Let's see. So first off, the count matches up. It's both like 4 rows. Second off, I just copied a random hash from the other side, and then try to like match them up. So here I can see that the event index is 8788 for this hash, right? And then flipping over to the other side, it's also 8788 for the hash. Looks like it. Sometimes it's a little bit, but like, yeah. Okay, so event index is 8788, and then the job starts with like 54289, and then on the other side, it's also the same. So now we're like ready to copy paste the whatever the tested query from like the actual UI over. So now like this is truly good. Like we know that this actually runs on the UI because whenever you change something, you like it's always good to test that it actually works as expected. So it does work as expected. So we're good. So now we're gonna kind of repeat the same process for all the 3 other SQL files. So next up, we have liquidity. So migration is on the very bottom, and then we have like liquidity, and then credits, and then all the way up to the job. So let's see, like basically the same process that we just saw over. So first, copy the liquidity log from V1 and paste it over to V2 side. and then start replacing with the correct syntax. So first delete the create table part because we only need the select statement now. So this is just for my own formatter. But yeah, so replace Keep3r Network with Keep3r Network Ethereum. And then we should, and there's this thing called Keep3r Network View Job Migration, right? So this, as we talked about, this is not really like a decoded source, but rather like a model of view that we're creating here. So we're gonna like see, like we need to deal with it a little bit differently, but we're gonna deal with that a little bit later. Yeah, so here I'm just making sure the syntax is correct. So like getting rid of the double quotation for all these source tables that I'm referring to. And then here the same gist, because we're doing like select union. So we should not do select star because we want to make sure like later on if the underneath source table changes, like we're still selecting the right column. So we're going to just like select the actual column instead of select star. And that way we can find the actual column is literally to go to the top, right? So here I already see what are the columns that are needed. So just like start pasting them to the bottom. Yeah. And then I try to like check for the count, right? And then like I want to make sure the count matches up, and then it does. And then I like paste it under to the bottom part. Okay, and then we're gonna just like start changing the syntax. So pretty much like as before, we're gonna like replace the syntax v1 syntax with v2 syntax. So things like the encode doesn't really like apply anymore because as I was just saying, like v2, the transaction hash is just like already a string. So there's like no need to manipulate further. So you can just directly refer to it. Yeah. I think in the interest of time, maybe I can fast forward this part. Anyways, that's saved as like part of the video on the slide. So later on, you can always like go back to the slide and refer to it. Because pretty much here, like I'm just doing the same thing. Like once you get how to do it, it's actually not that hard. You're just like replacing syntax and then making sure like to have like some better practices. Like don't do select star, do actually select actual columns and then unioning. So yes, I'm actually gonna fast forward this a little bit, so that we can try to like finish it a little bit more on time. Let me see. So if we go to here, oh, okay. So this is, I'm gonna find the part where we like start testing. Okay, so let's see. So here, okay, so this is important to also note. So remember we were saying that like, okay, so with the, wow, okay, sorry. Maybe I shouldn't have skipped. Okay, so I was saying that like because this migration is a little bit special because it's a model that we created like just now and not a source table. So here, in order to like to run our test successfully on the UI, we need to kind of like define this this table like separately, like temporarily up top. So here I'm just showing you how you can do that. So basically, you are going to go to the migration side, so like the SQL that you've just defined, copy, paste that over, and then just use that as like a common table abstraction. So with this migration temp, view job migration temp as, so you're gonna like paste whatever the logic that we've already tested that works on the other side over, right? So making a note for myself to remember to delete after testing. And yeah, making sure that I have the comma. But yeah, so that's how like we can test it. So like we just like need to make sure like all the dependencies are actually being filled on the same query. So now it's like actually getting a little bigger. But yeah, so once we like does all of this, then we're ready to copy paste this part of our SQL to the UI. So Control C, sorry, and then going to Dune and then going to paste it as a new query, and then okay, then we're gonna click run and see if it runs. Okay, actually no error so far. That's quite amazing, actually. Because normally when you write these logic, oh, okay, no error. Awesome. Okay, so now we're gonna repeat the same step as we were doing for the migration. So we're gonna go to V1 version and then find the view that we're trying to recreate. So here we're doing like the view job liquidity, right? So just gonna type Keep3r view job liquidity and find the view associated with it. So we want to compare the result from this side, like the view, the model we just created with the actual model. Okay, so we find the table on the other side. And so first we can check there's 27 rows, so the count matches up. Next, as always, we're going to take a random transaction hash. Okay, see the event index is 20. Okay, amount is 62. And then on the other side, also event index is 20, amount is 62. Okay, so we have some sort of confidence that this is the correct way to define the liquidity log. So we're gonna copy whatever we just copy pasted over back to our file, and then clean up a little bit. In that particularly, we're gonna like comment out the migration temp that we just added in just to help us test, right? Because this is like not the part that actually needs to be here. But in order for us to test the UI, we had to do that. So we're just gonna comment out this part. But yeah. Anyways, so let's see, because we are running a little bit over on the time. So I'm gonna actually skip the next two part. So the next two part, like what we were just covering, we're just copy paste and change the syntax from V1 to V2. So it's like quite similar to the first two iterations that we've just done. And if you need to follow along, there's just like videos for each of the copy paste test part, like the whole process that we've just gone through 2 times. You can just like refer to that. But I'm just gonna skip to the part where we assume that we've already done that. Now we're ready to replace hard-coded references with a Jinja templating. So remember, like way big in the beginning, we said we're gonna like combine SQL and Jinja to introduce like software engineering best practices over to data analytics side. Okay, so terminologies a little bit. So there are sources and there's models, right? So the sources are data that's created by Dune's team. Those are the raw blockchain tables, like transactions, logs, traces, and those are also decoded data and prices. And then in Jinja, the way you refer to it is double bracket and then source, parentheses, and then quotation, whatever you need. And then on the other side, there's the model. So the model are the select statement defined in SQL files. So those are like the models were like the abstractions that we're building on top of the raw and decoded data, right? So then the way you refer to that is by double bracket and then ref parentheses. Okay, so basically, because we already have like the SQL hard-coded version, all we need to do is replace these 4 files that we just hard-coded. Like we're gonna replace the sources with the Jinja templating. Okay, so let's start with Ethereum View Lab. So I looks like I forgot to clean up before, so we're gonna just clean up a little bit. Remember, like on the other side, we said we need to test and like we introduced a bunch of like CTE for testing. But yeah, so here we're gonna replace this. So because these two liquidity log and credits log are both models that I created just now, so they belong to the reference category. So I'm gonna call ref and then to refer to it. And then going back to the schema YAML to kind of like make sure copy paste the correct model name for this. So just copy paste the view job liquidity log over on this side. And then, yeah, going to try to do the same thing for the credits log, right? So the credits is also a reference, like a model that we just created. So yeah, gonna also do that. And then we're basically going to repeat the same process for view job liquidity. So here I'm just doing a little bit of cleanup. We no longer need the CTE anymore. Yeah, so here with the from, I'm basically control F to find the sources. And then if it's a underscore EVT type of table, then it's like a decoded table, then it's like a source, right? So we're gonna define this as a source. So double bracket source, and then gonna put the schema, which is Keep3r Network Ethereum, and then the actual table within the schema. Yes, I'm gonna like basically repeat the process for all of the source decoded source. Actually, I'm already making a mistake here. If you don't see, we're gonna find out later together what mistake I'm making here. So yeah, here you can see, same as before. It's once you get a hang of it, it actually can be quite repetitive, and you're gonna get real good at this real soon. Okay, so yeah, looks like here we've got a view job migration. So this is a model. So this should be a reference that we are calling. I'm going to start speeding up this because we already know what to do here. And looks like there's still a lot of copy pasting that's going on. Copy paste replace that's going on. Let me see. I want to get to the part where I show you. Oh, actually, in this entire video, I'm just copy pasting, replacing the source and references. And then assume that we've already done this. Again, you can always come back to the slide and refer to the process. We're going to run dbt compile. So dbt compile is going to compile our Jinja templating into hard-coded SQL, but it also will tell us like what's wrong with our code. And basically, when I ran dbt compile after that video, I saw that this source like does not exist. And I tried to think about it, debug it a little bit, and then realized the way I was referring to it was the case is wrong. Instead of like kind of like a camel case, I was like all lowercasing it, so it was wrong. So that's why like dbt compile couldn't find it. So I went back and then I changed everything, all the references to be the correct case. And then I ran dbt compile again, and it ran. Okay, so this was my other stopping point. I'm going to check the TET one more time. I can't click on it. Computer's struggling a little bit. Okay, cool. Awesome. No open question yet for this one. Okay, so we're almost there. Step 7. So now we're gonna configure some alias and materialization, and then we're like getting closer to like being able to actually raise the pull request. Okay, so the way you define this configuration and like also your materialization strategy is to open like a block on top of your SQL logic and start doing some sort of configuration. So here for the config block, I'm defining materialize equals to view. And actually, according to the feedback I later on received in my pull request, the view is the default materialization strategy. So you don't actually need to do this if you want a view. And then very quickly coming up after this, I will talk about like what exactly is materialization and like what you should do about materialization. But here I'm basically also setting up the alias for this particular model. I'm going to call it view job log. Again, this is also another part. I got feedback that we should not actually call view job log because what if in the future the materialization strategy changes? So I should just say like job log instead of view job log. So here I I opened Curve5's SQL to copy paste like the post hook strategy that they're using. Because I forgot the syntax, so I just opened some other file to copy paste. So basically all this does here, when we write the post hook, is so that like we expose this model on the UI. So whenever you go to Dune's UI Data Explorer, you're going to be able to see this table showing up on the Spellbook Data Explorer. And then I'm going to change it a little bit. And then this is the part where I'm going to give Waisahasa credit because he was the person that actually first developed this. But yeah, so that's how you can define config and materialization alias for this. And then you're basically repeating the same process for all of the 4 files involved in here. Obviously change the alias to the appropriate one for each of them. And then you're good to go for this part. So I'm going to pause here. You can keep watching the video afterwards. And then, as promised, we're going to talk about DBT materialization. So what is materialization? Materializations are strategies for persisting DBT models in a warehouse, right? So there are 4 types that are already built in. There's table, there's ephemeral, and there's view, and there's incremental. So for Spellbook, we basically only use view and incremental for now. So views are the default materialization strategy, so we don't need to specify it. And then the model that is built as a view is run each time. So what does that mean? So view is basically just logic without data being stored. So think of view as like a pre-saved SQL file, right? Like that we just wrote, but like no additional data is being stored. So the pro of it is like whenever view is run, it's always with the latest fresh data. But the con of it is that if you have a lot of data, it will take a really long time for the view to be constructed because it's literally grabbing the data everywhere to construct your view. So if you have a lot of data, then you should probably consider doing incremental. So incremental materialization allows DBT to insert or update records into tables since the last time that DBT was run. So you're incrementally saving the data into your table so that when you call this incremental model that you just built, it's going to be much faster. So let's just like take a quick look at an example of incremental view. So when you do incremental materialization, up top, you should define materialize equals to incremental, right? And then you should define like what partition it should be doing by. And then here, like down below, you actually also need to kind of like define like how are you incrementally adding data? So here it looks like the logic is that if you have data that's being added between now and the past 1 week, when this view is run, then it's going to be like saved incrementally. So yeah, so that's a quick example on how to use incremental view. Here it's just like a picture of how of everything that we just went through. And yes, I'm gonna just in the interest of time have us go through to the end. This is one of the last steps. We are almost there. Okay, so we are at the end stretch goal. So we're gonna just like add all the models that we've done to DBT project YAML. This is a very simple step. If you've gone through everything with us, you are almost there. So you are going to add some definition like in the DBT projects for the Keep3r Network that you've just done. So all you need to do is to create a new block for a Keep3r Network. And then you can basically imitate how other projects is doing it. You should do a schema, materialized, and then define the chain. You get the gist. So once you get like what DBT is doing, it's actually so much copy paste change, right? Like we've saw this like so many times in this presentation. Copy paste change, and then test a little bit along the way. But yeah, so this is what you should do. So you should add your project, your model in the DBT project YAML file. And then you are going to be well on your way to make a pull request and get that merged, and then you're well on your way to become an archwizard. Yay! But not so fast, right? Remember, I was talking about every pull request goes through pull request review process. So when I submitted my pull requests, actually my colleague, I wanted this to happen because I probably made some mistake where things can be more improved. So they gave me like a bunch of comments that I can start addressing and like improve upon. And after that process, then the spell will be like merged into the main branch. But one of the main things I wanted to highlight here in my review process was to start using variables when appropriate. So in my when we were doing things, there was a case where we were referring to the same token address 3 times, right? So that seems like we're referring to the hard-coded token address 3 times, this keeper token. So that was like a prime candidate for us to start using variables. So variables like are defined kind of like a little bit at the top of our SQL logic file. With this syntax, you can do like square bracket and then %, and then do set, and then whatever variables you want to call it, and then actual value. So whenever you refer to it later in the file, you just do like double bracket, and then you can refer to the variable that you've just defined for yourself. So that way, like when you read the code, it's like much cleaner and like easier for people to kind of like understand. We are going to skip this video. This video basically demonstrates how you can add a variable. And okay, cool. We've arrived at this point. Now you should be ready to claim a new Spellbook bounty. So here is a link to go to our Dune Spellbook space. And then here is where you will be able to kind of like start claiming bounties. So if I go into here for the DEX.trace migration, Sally, because it's such a hot thing, all the bounties have been claimed so far, but I have heard that the bounties are coming pretty soon. So if you want to have first dibs on the bounties with all the knowledge that you just learned today, you should keep monitoring this board and also be sure to join our Discord and start monitoring and like follow our Twitter, and then you will be the first to know whenever a new set of bounty is released. Well, thank you for everyone who have come today to learn about how to make a spell, and hopefully soon you'll be able to become an archwizard. Okay, I'm gonna look at the chats a little bit. Oops, the computer so old, doesn't even click open things. Yeah, maybe a series. I'm reading Marina's comments, maybe just like a series. Yeah, I think it's a lot to go through just like in one session. Like we've spent like an hour and a half doing this already. Thank you, Boxer. Thank you for your support. I'll stop sharing screens. How do I? Okay. Thank you for everyone who has come today. Yeah. I guess join our Discord if you have any questions, and see you later.
Thank you so much, Agape, for doing this workshop. So amazing to have you. And
thanks for
yes,
having me.
Would love to have you back. And yeah, find the recording soon on my YouTube channel and check out the links. And thank you again.
Well, thanks for having me. Have a good one.
You too. Bye. Thank you.